because you know why? I'll get over it. Now we never really drop those. So what happens here is now we all understand that the square root of -1 is I. And now that if we square I, this is the important part now, I squared is equal to what?
-1.
-1.
Why?
Why? Because what's the square root of 4?
2.
2. What's 2 squared?
4.
It's still the same thing.
But I thought.
Outside radical.
Wait, I thought it could be anything we want, so we're using our imagination.
The imaginary number is as standard as the square root of -1. So what everything boils out to being here, square root of -1 is your imaginary number, and I squared is -1. So as we go through these things, what I want you guys to start thinking about is not only are we working with what are imaginary numbers, we are working with what are called complex numbers. And the complex numbers have a specific way of being written. You will see complex numbers in standard form like this, a plus b I, where a and b's are integers, okay? Notice how the I value is always second. It's kind of like the standard way of writing it. So if I was going to write 3 minus 4i, I always put my I value second. The complex number is written as an integer plus or minus something with an I value. When they add them together, they throw them in parentheses to show that they're being grouped together. So when I have two complex numbers being added together, it might look like this. 3 minus 4i plus 6 plus 8i. That's exactly what you do. When you are adding, or if you are subtracting these things, what I want you to do, especially with adding, is treat I like a variable. Treat it kind of like a variable. So you're combining like terms and stuff. Yes, sir?
So this is going to look like standard form, and then I is going to be -1.
Not yet. Where I is not -1 until it's squared, and that'll be when we're multiplying.
Yeah, so what it would end up looking like is like 4, so it would be -4 plus,
Wait 2 minutes.
all right,
When we're doing addition stuff, what I want you to do is, remember, treat it like you're doing combining like terms. Rewrite it without the parentheses. 3 minus 4i plus 6 plus 8i. Combine your like terms. Put the integers first. What's 3 plus 6?
9.
What's -4 plus 8?
8, 4.
And your answer is that, 9 plus 4i. When you're adding complex numbers together, you're basically combining like terms.
Wait, you don't have to like solve it, or
There's no equation, there's no nothing.
it's
All this is
I equal like -1.
that's what Leek was getting at. We're not solving anything. There's no equations. All I'm telling you to do is treat it like you would a variable when you're combining them. We're not solving for I. We're not finding anything here at all. We don't worry about I squared stuff until we're multiplying or dividing. And I'll explain to you how all this is just simplification. Yeah.
What is the name of this section?
Complex numbers. It's 5-4. It's still the same complex numbers. Complex, or you want to call it integer numbers for now. The only thing that's different with subtraction,
Oh, you gotta keep it.
yeah. You're basically, when you are subtracting, notice how they're writing up as complex number minus complex number. What happens here is that you want to treat this subtraction symbol as a -1. And when you go to rewrite it, you're distributing the negative to both terms.
So it'd be +2 and +.
Correct. So when you write out, it gets -3 plus 7i minus 2 plus 4i. And then you combine your like terms. That's the only trick with subtraction, is to remember to distribute the negative value to both parts of the complex number. So what's -3 minus 2?
-5.
7 plus 4.
Plus 11.
So adding and subtracting, yeah.
So is it always false if you set that equal to an integer, a complex number?
Yeah. We're not setting anything equal to anything. You will not be setting anything equal to anything here. There's no equalities. Okay? Nothing at all. Yeah. All we're doing is, this is just basic simplifying. Think of this, like I had on the next slide here, think of this as just plain old boring combining like terms. All this is just combining like terms. So take a second and try these two, remembering that you have to distribute out the negative when you're subtracting. A lot of times when you're adding or if you're subtracting, you don't normally usually have to write out the full problem itself. A lot of times students get away with just seeing what it is, writing it without the parentheses, and then just distributing that negative right away. When we get to multiplying, there's a little bit more work involved. Not much though.
So if we do it in our head, so
No big deal.
it's, but we say rather no, it's supposed to be. That was so good.
That was something I would have said. This is bad.
Huh. Don't call yourself bad, this was rude.
I'll get over it.
You always are getting over things like.
I'm so bad I know I'm good.
You're so bad you know you're good, which makes you good. Dude.
Oh, so that's why you're sugar, because you're Breaking Bad.
Yes. I'm part of that meth ring that's in the
Yeah.
calc now, in case you didn't read the paper.
That's the method. You didn't see that? Yes. I read that in
This is real tough now. What's 4 plus 3? That's negative 1 plus 2. What'd you guys get for the other one?
Six. Wow.
Just 6. Yes, sir.
I'm gonna make you a poster that says, what is it? Warner Earthberg or something like that. What's his alias? It's like Warner Heisenberg.
I never saw one of those episodes.
You've never seen the show?
I know. Fontana yells at me all the time for never seeing it. I just never. Maybe one of these days I'll Netflix it or something. I never got into it. I just never had time. I don't know. So here's the next part of this: multiplying. When you are multiplying values of I, we start with stuff like this. I have 2i times the quantity 3 minus 4i. Complex number times a complex number. Now, normally in your minds you're thinking, okay, that's nothing more than a distribution property,
No.
right?
No.
So you distribute out. What's 2 times 3?
6.
So I have 6i. Remember, treat it like it's a variable. And then what's 2 times negative 4?
8i squared.
So I get negative 8i squared. Now, what is I squared equal to?
-1.
Negative 1. So this is where
Oh, that's
I squared equals negative 1 is really important. So you get 6i minus 8 times negative 1. 6i plus 8. But, what do you have? What's that? Exactly. The proper way to write these is always to put the integer first. Hmm? Do I know why? Why? No.
We're occasion down in Alabama.
Yeah.
They don't have any math down there?
1983. That's a good Halloween.
Did I say that out loud in front of a ball? I'm sorry.
That's a good Halloween joke, Mr. Murphy.
Yeah.
She's gonna throw something at me.
No, the
Oh, that's right.
Yeah.
Yes, that's right. I forget because they can only count like 4 because they're missing fingers.
Yeah, they were on a mission, like a mission.
They're on a mission from Gad. Oop. Blues Brothers. We're on a mission from God.
I've seen that
What do you do?
Distribute.
When it's binomial times binomial, what do you do? Foil. So you would FOIL. 2x squared plus 4x
Oh, that's what they call it?
minus 4x
First, outside, inside,
minus 8.
and you get.
Combine your like terms, you get 2x squared minus 8.
If you're lucky.
What do you think changes when
Nothing.
I is involved?
Nothing.
Probably negative.
Absolutely nothing.
Absolute zero.
Oh, you went there.
Mr. Murphy, I have to tell you a good Halloween prank after class.
Okay. So what happens when you're dealing with imaginary numbers like this, if we have 4 minus 5i times 3 plus 2i, I do the same thing. I FOIL them out. I start first, outside, inside, last. So first gives me 12 plus 8i minus 15i minus 10i squared.
Nobody has
And that equals 10, so that's positive 10 at the end. Just
Very
tell
good.
yourself.
Good. That's very good.
Know that.
Remember, negative 10i squared is the same thing as saying plus 10.
So you're
Okay.
gonna have 3i. So it's
No.
Never mind.
22
Never mind.
minus 7i.
So when you combine your like terms, what's 12 and 10?
22.
8 minus 15?
Negative 7. Minus 7.
Negative 7i.
The only thing you have to pay close attention to when you're working with I values as you're multiplying out is you gotta remember that I squared is always negative 1. So always, when you're multiplying out your last step there, rewrite whatever that is, whether it's plus 10 or if it was minus 9. Yes, sir.
I think I like this.
Good.
Oh, get it? He said
Or I could say negative 1 squared. I think I like this.
Try those 3 real quick.
Oh my goodness. Is this literacy?
Let's see, we get negative 10i plus 5i squared, so it becomes negative 5 minus 10i.
Yes.
Okay? Everybody agree?
Oh,
FOIL out the next one. Negative 7 plus 14i minus, or excuse me, plus 4i minus 8i squared. So that's plus 8, so I get 1 plus 18i. Everybody agree so far?
I.
Missed a sign. Yes, I keep looking back and forth so to make sure. And then lastly, did you notice a pattern in that last one?
They cancel each other.
The middle terms dropped out, didn't they?
Yeah, it's because they're the opposite and the same.
Exactly. So you wind up with 36 minus 9i squared, which is 45.
So it gives you a trinomial.
What happens here is that we use that idea of what's called multiplying by a conjugate. We use multiplying by a conjugate because what happens when you multiply by the same terms with opposite signs, what happens to the I?
Disappears.
It goes away. So what do you think you have to do when you divide?
Break the I over.
I know, I typed that wrong. I didn't spell it
Wait,
right.
it's
You never saw it. Hence my English skills are impossibly awesome.
impossible.
That elephant is
You're so funny.
You're so funny. Get it? Yeah. It's not even a joke, it's a prank.
Yeah, it's a prank, so please don't call it a joke.
Yeah.
Anyway,
I'm offended.
just like when you are working with radicals, we don't like to have radicals in the denominator. When we had the square root of 144 over the square root of 11, we got 12 over root 11, we multiplied by root 11 over root 11, and we got rid of the radical. Same idea here is we don't want to have any imaginary numbers in the denominator. And in order to be able to get rid of the imaginary number in the denominator, you have to multiply it by its conjugate. So if I multiply the denominator by the conjugate, what do you have to multiply the numerator by?
I.
The conjugate.
So is it I?
No.
Oh.
In this case here, it's 1 minus 2i, so I'm going to multiply the top and the bottom by 1 plus 2i. Now, these style problems take a little bit longer than just the multiplication one because you have to multiply and FOIL out twice.
Oh, that's so.
Okay? So the denominator stuff should be relatively easy because it's first term squared, last term squared. The middle term drops out. You get 1 squared minus 4i squared. Negative 4i squared is how much? Good. So it becomes 1 plus 4. So my denominator is now 5. When you are dividing these imaginary complex numbers out, work with your denominator first, and then go back and take care of your numerator.
You're supposed to FOIL on.
Yep, you know, you FOIL. So you get 5 plus 10i plus 3i plus 6i squared. When I combine that stuff out, I have 5 plus 13i minus 6, because positive 6i squared is negative 6. Perfect. So your final answer becomes negative 1 plus 13i all over 5.
All over. I love that.
Okay? Multiplying by conjugate usually takes a minute longer because you have to FOIL twice. One thing I will warn you about when you are doing those, sometimes when you're looking at the solutions in the back of the book, it may simplify the fraction further. It may not. An easy thing to remember is that if all 3 terms are even, it means you can divide them all up by 2. Something like that, yeah.
Are you gonna
I want you to simplify it as much as possible. I'm probably not going to dig you so much on that tomorrow since we haven't really had a chance to review any of it. But if you get this far, but what I'm saying is that if you get a solution that's this,
Wait, this is not our this one?
yeah. If you get something like that when you multiply out, when you divide out, what can you factor out? And you're done. See what I'm saying? You can do that. That's what I'm looking to make sure you do. That's all I'm looking at. The answer's in the back of the book to do that. Yes, sir.
So this was like in real life, and you asked me a question and I answered negative 1 plus 13i over 5. Isn't that not a real number, so not a real answer?
It's an imaginary answer.
Alright, so I didn't help you out at all.
No, you didn't. But you use imaginary numbers in electrical engineering when they're dealing with ohms and stuff
So
like
why
that.
would we ready to get unless we're going to engineer?
Because it's the process. You use it again in pre-calc. They're doing it right now. They're using it the step above what we do right now. Anybody, if you know anybody in pre-calc, they're doing complex numbers right now. They're actually graphing them, I think. I'm graphing it right now.
Are you really?
Was that a Yannick joke?
It's an imaginary number. that we graph.
It is
Oh,
half.
not that.
Yeah. I graph it.
I thought you meant like that, actually like were you able to graph things in your head?
But you can't. X squared, it's a parabola, it's up like a cup.
And
She just looked up into your brain, but oh my god,
what? Come on. Okay. No talking.
do this problem, please.
No.
Alright. I'm sorry.
You'll just tell me that. Not
Because you're a bad.
Math is in the morning, what is this?
Wait, can we math meetings when?
You're not on the team, right?
Oh, so then I don't know that?
Not till next Monday. I have a mandatory meeting next Monday, because I need
On Monday.
next Monday, because I want to make sure that I want to make sure everybody's on the roster, supposed to be on the roster. Everybody knows what's going on, and we're going to do our shirt order.
How many can we miss again?
None.
And then is there like some,
Are there
I've-
tryouts?
shut up. I just feel like a big circles.
Seb's making the those. I'll get those. I'll get it to you tomorrow.
You don't get. Alright, I'll go to some.
Yeah.
I'm pretty sure. Takes me a while to foil them.
Yeah.
It's okay. No big deal. Since we are running a little short on time here, I want to make sure you get the assignment written down.
Is it over zero?
No. When you, what is the conjugate of 1 plus I?
1 minus I.
1 minus I. So I multiply top and bottom by 1 minus I, which means my denominator becomes 1 minus I squared, which is 1 minus negative 1,
So it's 2.
which is 2.
Why is it 1 minus I, not 1 plus I?
It's 1 minus a negative 1, and
Read it from here.
Oh, okay.
that's where I get 2.
Oh.
Because when you FOIL that out, your last term is minus I squared. All
Wait,
right?
when you have a negative of something that is neither positive or negative.
Yo.
You can. If it's a cubed I, then they can be a negative I. Negative is the opposite of square root of negative 1. Yes, sir. I don't know.
No,
Whichever.
food asking space, I don't know if ask.
Never mind, so is it over two? Yeah.
So 2. That's usually where people mess up. They'll forget that it's minus and negative, and you get plus. Yeah.
This is like, I think it'd be kind of funny for Halloween, you made people answer a math question before you gave them candy.
FOIL at the top, you get 3 minus 3I minus 4I plus 4I squared. Plus 4I squared is the same thing as what?
Minus 4.
Negative 4. So this is 3 minus 7I minus 4. So your final answer is negative 1 minus 7I all over 2. Remember, when you are doing these problems, take care of that denominator first, and then go for it. All right? Do these for tonight. I'm giving you some more odd numbers so you can check your answers. The quiz tomorrow does consist of everything we've done in the chapter. It will have the graphing stuff. When you're talking about graphing, remember, you have to be able to identify vertex. Is it a maximum? Is it a minimum? Is it up like a cup or down like a frown? What is your axis of symmetry? Things like that. Table, you'll be able to use the table function in your graphing calculator to be able to find your symmetric twins and whatnot. 5.2 is all about factoring. 5.3, 5.4, equations solving with quadratics. And then the tail end of 5.4 was working with imaginary numbers like this. 1 billion.
Hey guys, math team.
All right.